So, for finding out the thickness of the plate, what are the things required to do? We need to find out permissible or you can say allowable stress of this plate. So, permissible or allowable stress, how to find out here? So, permissible stress or allowable stress we can find out generally is sigma A is equal to endurance strength divided by factor of safety, that I have already discussed. So, endurance stress is given, endurance strength we find out as 76.96 and factor of safety is given as 2. So, what is the permissible or allowable stress we got? This allowable stress will be actually 38.48 MPa. So, allowable stress now is we find out. Now, we need to find out what dimension of the thickness of that plate. So, for finding out the plate thickness T, which is our next step. So, plate thickness T, how to find out plate thickness T? So, we know plate thickness T equal to sigma equal to your applied force divided by what it is called cross sectional area. Cross sectional area is actually your, always you should keep it in mind here, which cross sectional area we should consider. You see this component generally we make. So, it has a dimension of 100 and it has a dimension of 50. So, it is subjected to load P. So, here which cross sectional area we should consider, whether we should consider the cross sectional area of this means lower dimension portion or higher dimension portion. Definitely we should be in safe side, here we should consider the cross sectional area of lower dimension portion, because if we consider the lower dimension portion, there is a chances of high stress developed in that types of component. This you should keep it in mind. So, here generally we should consider P divided by what it is called, you can say 50 into thickness of that plate. This you should keep it, because lower dimension on, if you take higher dimension on, generally this will give you the minimum stress develop in this what it is called component. So, we should consider that component where there is a chance of highest you see or high stress development. So, here the high stress will develop where the cross sectional area will be less, because generally stress equal to load by cross sectional area, its the stress is inversely proportional to cross sectional area. This you should keep it in mind. That means, lower the cross sectional area, higher will be the stress developed. This you should keep it in mind. So, that is why you need to consider this, which I have already discussed for nominal stress calculation. There also I have discussed these things. Okay. So, that there also I told you that we should consider the minimum cross sectional area for finding out the nominal stress. Same things here also we need to use. Sigma is given as, this will be equal to, P is given as 50 kilonewton. So, 50 into 10 to the power 3, its magnitude is given 50 into T. So, this will give us a plate thickness T equal to your 25.987 millimeter. So, what is our design thickness of the plate? So, design thickness of the plate generally we can easily calculate, that is your 25.987. We can consider as 26 millimeter, no problem. Generally higher thickness you can consider, but not lower thickness you should consider, because higher thickness if you will consider, then you see you can say you will be in a safe side. If we consider lower thickness, then what happens, you will not be in safe side. This you should keep it in mind, but you can consider this is your design thickness. Okay. Now, we will solve another problem which is for finite life design problem. This now I am going to discuss. it is also subjected to a what is called reverse types of loading. This we should keep it in mind. So, whatever the problem here I am solving, this everything is related to reverse types of problem. Okay. So, we have not yet come to fluctuating types of loading case, that I will discuss later on in subsequent lecture. I will discuss everything. So, what is the problem statement here? It is so here two mild steel plate, here you can see two mild steel plate of dissimilar thickness. So, here thickness is given as dissimilar, that means thickness is different, one is 8 millimeter, another one is 14 millimeter, are butt welded is subjected to a completely reverse axial stress as shown in figure. So, it is subjected to a reverse axial stress. If this is the plate thickness and its configuration is given. So, one plate is 14 millimeter, another plate is 8 millimeter is given. If the expected reliability is 95%, so for expected reliability 95%, Kc is given as 0.868, surface finish factor K is given as 0.75, the size factor is given as Kb equal to 0.85. Then calculate the fatigue strength of the specimen for a finite life of 1 lakh cycle. That means, if it is subjected to a what it is called completely reverse axial load, then what happens, its and its ultimate strength is given as what is called, its ultimate stress is given as 400 MPa, then you see here Notch sensitivity factor also given as 0.85, then you need to find out what is the fatigue strength for n is equal to 1 lakh cycle, for n equal to 1 lakh or 10 to the power 5 cycle, what is the fatigue strength SF, this we need to find out. So, what are the things here it is given? So, first of all we know the design procedure for what is called finite life types of design problem is, we need to draw a SN curve. We need to draw a SN curve. In this SN curve, this is a log plot, you can say log 10 n, and this is generally log 10 SF curve. So, here we need to define 2 points A and B. So, what is A? You know this thing 0.9, that is your S ultimate, comma you can say this number of cycle is 10 to the power 3. So, it log 10 to the power 3 will be, you can say 3. So, this will be this A point will be, you can say 3 point, you can say 3 comma log 10 0.9 sigma ultimate, and B is corresponding to, you can say 6 comma, because this is corresponding to 10 to the power 6 cycle log 10 as SE, endurance strength. So, here ultimate stress, here generally given data is ultimate stress is given as 400 MPa. Okay. This ultimate data given as 400 MPa. So, here based on this ultimate data, A, B point we need to find out. Before going to find out B point, first of all we need to find out what is your endurance strength. So, endurance strength generally we can find out by Marine equation. Marine equation, endurance strength you can write as Ka, Kb, Kc, Kd, Ke, Kg into 0.5 for steel, this is a mild steel plate. So, S ultimate stress, correct. These are the things you know. Now, Ka is given. So, Ka is given. So, Ka is given as what? 0.75. Kb is given as 0.85. So, I am putting all these things. Kc is given as what? Kc is given as this is reliability factor for 95%, Kc is given as also 0.868, temperature effect is not considered, that is why it is 1, and this load factor is axial load, axial types of reverse stress. So, it will be axial loading case, it will be 0.85. Okay. Now, we need to find out what is our Kg, Kg equal to you can say 1 by Kf, okay. And this 0.5 into ultimate stress, this is also given. So, this is also given, 0.5 into ultimate stress is 400. So, this will give us 200 MPa. So, this endurance strength we need to find out based on this equation. So, here everything is given, only one data we need to find out, that is our Kf value. This Kf value, how to find out this Kf value? Generally for finding out Kf value, we know for dissimilar thickness of plate, this Kf value we can find out. First of all, we need to find out Kt. For dissimilar types of plate thickness, Kt equal to, we know these things, that is actually 1 plus 6 into E by T1 divided by T1q plus T2q divided by T1q, correct. These things is known to us. What is T1? T1 is actually thin plate section. Here T1 is given as 8 millimeter, always you should keep it. T1 is thin plate, this is our T1 and this is our T2, okay. This you should keep it in mind. So, T1 is given, T2 is generally given as 14 mm. Now, what is E? E is the offset distance between two plate neutral axis. What is the offset distance between two plate neutral axis? How to find out this offset distance? For this thin plate, you see the neutral axis will be the mid length, you can say, and for this thick plate also the neutral axis will be the mid length, correct. Mid length or you can say middle thickness of this plate. So, for this thin plate, this middle distance from the base line is 4 mm, because half into thickness 8, that means will be 4 mm, and half into 14 will be, you can say, 7 mm. So, this distance between these two line is called this offset of this dissimilar joint. So, here offset will be 7 minus 4 equal to 3 mm. This you can easily find out from the geometry of this joint configuration. So, here E is calculated based on the above procedure I have already told, that means distance between this two plate neutral axis, this is the offset distance, is given as 3 millimeter. So, everything is given in this equation of Kt. So, what are the Kt value we can get? 6 into 3 divided by T1 is 8 divided by your 8q plus 14q divided by 8 cube, okay. So, this will give us a value of Kt equal to, you can say, 1.354. So, Kt is now known. Now, what are the things we need to find out? Kt is 1.354. So, we need to find out what is our Kf. So, we know there is a relationship between Kt and Kf in terms of notch sensitivity factor Q. So, Q is given as, what is the relationship? Kf equal to, generally we know as 1 plus Q into Kt minus 1. This equation is also known to us. So, this will give us, you can say this will give us Kf equal to, this will give us Kf is equal to 1 plus, here q is given as 0.86, kt I have already found out, that kt, that is your 1.354 minus 1. So, this will give us kf is equal to, you can say, what is the kf value we are getting from here? This will give us a kf value which is actually 1.304, 1.304. So, 1 kf is known, just put this value in this equation, let this is our equation number 1, that is your marine equation, kf equal to 1.304 if we put in this equation number 1. So, what are the things from equation number 1, what are the endurance strength we got? So, from this equation now endurance strength will be, directly I am putting this kf value is 1.304, here endurance strength will be general, directly if we just do the calculation, you will get endurance strength equal to 72.15 MPa, megapascal, MPa. Now, what are the things we need to find out? We need to find out now what it is called, what is the fatigue strength of this welded specimen SF, that I need to find out. For finding out this thing, what are the things required to do? We need to draw the, so this is our log 10 N number of cycle, this is our log 10 SF. So, A point we need to find out, what is our A point? So, A point is, you can say 3 log 10.9 sigma ultimate stress or S ultimate stress. So, generally here you see log 10.9 into ultimate stress is given as 400, this will give us a value of, you can say 2.5563, 2.5563, okay. And another point B we need to find as 6 point what, log endurance strength, log 10 endurance strength. So, this will give us log 10 endurance stress is generally given as, which we have already calculated, 72.15. So, this will be equal to generally 1.8582, 1.8582, 82. Okay. Now, based on this, generally what we can get, A B point will already we got. So, A B point, so A point and B point we got. So, B point, this is our 6, A point generally here it is corresponding to number of cycles. So, this will give in log curve, that is your 3 and 6, and A point already given as 3.2.5563. So, here you can write directly, here we can write 3.2.5563 and B point is given as 6, 1.8582, correct. Now, we need to draw a straight line. Okay. This straight line AB generally is used for design the problem for finite life cycle. So, here generally for number of cycle n is given as 1 lakh cycle, 10 to the power 5 cycle. So, in log curve, log 10 n will be, you can say log 10 to the power 5 will be equal to your 5. So, we need to draw this log 10 n in this log curve. So, that I am drawing, I am using a separate color, then it will be easy to understand. Okay. Let us you see. So, this is our number of cycle log 10 n, already I have given as 5. So, you see corresponding to this log 10 n, we need to draw a parallel line, which is need to draw a vertical line which is parallel to, you can say, ordinate, and which is cutting this AB line at a point F. I have already discussed in previous slides. So, you see, so corresponding to this number of cycle n, we need to draw a vertical line which is cut the AB line at a point F. So, corresponding to this F, we need to draw a horizontal line. This horizontal line generally cut this ordinate. Ordinate is vertical line, always you should keep it ordinate at a point E. So, this E, at this E, whatever the log 10 SF, this will give us log 10 fatigue strength value. This SF will, we need to find out what is this log 10 SF. So, for finding out these things, we need to draw another line which is horizontal line and passing through the point B. Let us consider this, cut this ordinate at point C. So, from the similarity of two triangle, so now we will find out from similarity of triangle, what it is called AEF and triangle ACB, what are the things we can got? We can get, we can write AE divided by AC is equal to, we can write as EF divided by CB. So, here always you should keep it in mind, here A is given as log 10.9 ultimate. So, here I am writing these things log 10.9 ultimate. Okay. E is given as E is given as log 10 SF. This SF is the fatigue strength which we need to find out corresponding to 10 to the power 5 cycle. This is, that means what is the SF value, this we need to find out. Okay. So, AE, what is AC? Again AC is given as log 10, A is given as 0.9 ultimate stress and C is given as log 10 endurance strength. This will be equal to your EF. So, EF equal to, always you should keep it in mind, F is given as 5. Here you can see from this above diagram you can see 5, and here E is given as, generally E corresponding to a you can say abscissa value which is actually 3. Always it is not 0, this you should keep it in mind. Similarly, CB, generally here the distance is generally 6 minus again 3, this you should keep it in mind. So, here generally there is a chances of mistake. Okay. That is why what happens here, always this is not 0, this is should be 3, this you should keep it in mind. Now, already we know log 10.9 ultimate, it is, its value is 2.5563. So, 2.5563 minus log 10 SF is given divided by 2.5563 minus log 10 what it is called log 10 endurance strength corresponding to also I have find out, that is actually 1.8582. So, I am putting directly 1.8582. So, corresponding to these things will be 2 by 3. So, this will give us a value, directly I am just putting by doing the calculation, what you will get? We can get 2.5563 minus log 10 SF, this will be equal to your 0.4654. So, if we calculate these things, generally here SF generally we can get as 123.282. This you should keep it in mind. So, this is the, so corresponding to, you can say, number of, so corresponding to n is equal to 10 to the power 5 cycle, our fatigue strength value SF, that is your fatigue strength, or you can say fatigue design strength SF equal to your 123.282 MPa. So, based on this SF value, generally what are the things we need to find out? We need to decide our what is called dimension, which what should be the length of the plate, what should be the dimension, that means length of the plate or length of the weld, that we can decide based on this SF value. This you should keep it in mind. How? If the factor of safety is given, generally based on this SF value, generally whatever we need to find out allowable stress. Allowable stress generally this fatigue strength divided by factor of safety. Again, let us the load is given. So, if allowable stress equal to applied load divided by its what is called cross sectional area, okay, that is actually cross sectional area P by A. So, based on this P value, or if this stress value is directly given, that we compare with this allowable stress, and what happened based on these things we need to find out what is the dimension of the structure. So, here generally we need to find out this data, that is why this is sufficient. Okay. So, this way generally we can design what is called finite life problem. Next lecture I will discuss what is called how to use rain flow method and Minard's equation for cumulative fatigue damage calculation, and also I will solve some problem on what is called rain flow method, as well as what is called by using Minard's equation, how to find out fatigue damage, and based on those things how to design a finite life design problem, that also I will discuss. So, these are the references which I have followed for this lecture. Thank you.